Today, we're going to roll up our sleeves and build the future of healthcare. What you're about to see is a clear, step-by-step blueprint for creating a remote ECG monitoring system, one that's designed specifically for the world of 2026. So let's jump right in. Okay, let's kick things off with a big number, $29.13 billion. That's what the remote patient monitoring market is projected to be worth by 2030. Now, that is a huge flashing green light for opportunity. But behind every big number in healthcare, there's always a much more important and much more human story.
Because see, this isn't just about a business opportunity. Not at all. We're talking about tackling the #1 killer on the entire planet, cardiovascular diseases. They are the leading cause of death, full stop. So the system we're designing today, it's not some cool new gadget. It's a lifeline. It really is that simple.
All right, so here's how we're going to break this down. We've seen the opportunity. Now we'll walk through the 4 essential parts of the build. First up, the hardware. Then we'll dive into the algorithm, the brains of the operation. After that, the cloud platform that ties everything together. And finally, and this is a big one, we'll get into the 2026 rulebook, the stuff that makes this a real compliant medical device. Okay, first things first. Step 1, the hardware foundation. None of this works if you can't get a good, clean signal from the body. So everything, and I mean everything, starts right here. And that signal starts with the point of contact, the electrodes. Now, you might have seen the old school ones, these messy, wet gel pads. Forget about those. For a 2026 wearable, it's got to be dry electrodes. And here's why. The whole point of this is long-term, continuous monitoring, right? Nobody's going to wear a sticky, irritating patch for days or weeks. They just won't. So this isn't just a matter of comfort. It's about getting people to actually use the device, which means you get the data you need. Okay, so once you have the electrodes, the electronics behind it are actually pretty simple. It's kind of amazing. You basically have 2 main components, 2 little heroes doing all the work. First, there's the sensor. Think of it like a super sensitive microphone, and its only job is to listen for that faint electrical thump-thump of the heart. And then you have the microcontroller. That's the little brain that takes what the microphone heard, cleans it up, and gets it ready to send out to the world. So let's just nail down what each one does. The sensor, it's all about noise cancellation. Its job is to filter out all the electrical static from your muscles and the environment and just give you the pure, clean ECG signal. Then, the microcontroller grabs that clean signal, uses its built-in Wi-Fi to shoot it up to the cloud, and here's the magic part. It does all this while using barely any power. That's absolutely key for battery life. All right, so we have a clean signal. Awesome. But a stream of raw data by itself is, well, it's just a bunch of numbers. It doesn't mean anything yet. That brings us to step 2. We need to give this system a brain. We need the algorithm. And this is the question, right? The absolute core challenge for that brain. In this giant, noisy ocean of electrical data, how do you find that one single, perfect little signature that says, this is a heartbeat? And you have to do it instantly, and you can't be wrong. Well, the answer is actually really clever. It's elegant. The algorithm doesn't try to make sense of the entire complex waveform all at once. Nope. It's laser-focused. It's hunting for just one thing, that big, sharp spike you see right there. That's called the QRS complex. That spike is the unmistakable signature of a ventricle contracting. It is the heartbeat. It's simple. Find the spike, you've found the beat. But, and this is a big but, how the algorithm finds that spike is everything. The old school algorithms, they're like classic muscle cars. Super powerful, for sure, but they are total gas guzzlers when it comes to processing power. You can't put a V8 engine in a tiny wearable, right? You'd kill the battery in minutes. So for 2026, we need a modern, efficient engine. The new algorithms are 5 to 20 times more efficient. That means you get that real-time analysis without draining the battery. No delays, no data loss. It's a game changer. Okay, quick recap. Our device is grabbing the signal. The algorithm is spotting the heartbeats. So far, so good. But all that amazing insight is still stuck on the device. How do we get it from the person wearing it to the clinician who needs to see it? Well, that's step 3. We need to build the bridge. We need the cloud platform. The easiest way to think about this is like a 4-step journey. First, the wearable on the patient collects the data. Easy enough. Second, that little chip on board encrypts it, super important, and beams it over Wi-Fi. Third,
It hits the cloud servers. This is where the heavy lifting happens. More analysis, secure storage. And finally, step 4, it gets served up as easy-to-understand charts and alerts for both the patient on their phone and the doctor on their dashboard.
And that last piece is really important. You're not building one interface, you're building two for two totally different users. For the patient, it needs to be a simple mobile app, something clean, reassuring, maybe even a little motivating. But for the doctor or the clinician, they need a command center, a powerful dashboard where they can see data from dozens of patients, get critical alerts, and spot trends without getting overwhelmed.
And this brings us to a really critical point about the cloud platform itself. You can't just, stitch this together with off-the-shelf consumer apps. Those days are over. As this quote makes really clear, the grace period we had where you could use stuff like Zoom or FaceTime for telehealth, that's ending. By 2026, if you're in this space, you need a platform that was built for healthcare from day one, no exceptions.
That is the perfect segue into our final and honestly maybe the most critical step of all. The tech is cool, the algorithm is smart, but none of it matters if you can't legally put it on a patient. So let's dive into step 4, the 2026 rulebook. This is where we talk about the non-negotiables. Let's start with the big one, HIPAA, patient privacy. The main thing you need to know for 2026 is that the wiggle room is gone. What used to be flexible guidelines are now hard, testable requirements. Things like multi-factor authentication for logging in, mandatory. Encrypting data when it's flying through the air and when it's sitting on a server, mandatory. It's not a should-do list anymore. It's a must-do checklist, and you will be audited on it.
Then there's the FDA, and their whole mindset is shifting. It used to be about proving your device worked when you submitted it for approval. Now they want to know what your plan is for the entire life cycle of the product. You actually have to show them how you're going to keep monitoring its performance out in the real world, tracking its accuracy over years. And here's a huge new one. You have to proactively check for algorithmic bias. You have to prove that your smart algorithm is just as smart for every gender, every race, every body type. Fairness is now a design requirement.
And so there you have it. That's the blueprint. You've got 4 pillars. Efficient hardware to get a clean signal, a smart, lightweight algorithm to make sense of it, a secure cloud platform to connect everyone, and all of it has to be wrapped in a bulletproof layer of regulatory compliance. Get those 4 things right, and you've got a system built for 2026.
So we've got the roadmap, we know the tech, we know the rules. But this leaves us with a really big question, doesn't it? Knowing how to build it is one thing. But what's the biggest barrier to actually getting these devices to the millions of people who need them? Is it still cost? Is it the nightmare of trying to integrate a new system into a hospital's ancient IT infrastructure? Or is it something more human? Is it about earning the trust of patients, convincing them to wear this thing and rely on its data? That right there is the next giant puzzle we all have to solve.